Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about thermistors. So, what is a thermistor? Well, we can break that down to two different words. This bit, over here, stands for the word thermal. Okay? This bit, istor, stands for the word resistor. Basically, it's a thermal resistor. It's a resistor which depends upon the temperature. So as you change the temperature of the thermistor, the resistance will change. Here is our circuit symbol. So that is the symbol for the thermistor. It's a normal rectangle. We've got a hockey puck going through it. So make sure you can memorize that. So a thermistor is a resistor which depends upon the temperature. Okay, mixing up my words here. But fine, now we can move on. So let's say you're asked to investigate how does the temperature affect the resistance of a thermistor. First of all, you have to put the thermistor into the circuit. So let's make a circuit very similar to before. We've got the power supply over here. We've got a thermistor. Yeah, we're going to put an ammeter to measure the current in series. The ammeter is placed in series. We also have a voltmeter around the thermistor. Okay, now all of it, let's say I was to heat this whole room up. So we're going to heat let's put the voltmeter around over here. There we go. The voltmeter's around it. Now, if I'm going to put that thermistor, we're going to heat that thermistor actually now. So let's heat up the thermistor. So what happens when we heat up the thermistor? Well, we know that the resistance of it will change. So if we were to plot a graph, well, let's say, I don't know, let's do our table of results first. Voltage and current. So we have voltage, current, and let's say we're going to change the temperature. Let's put that temperature first. So let's go. So we're going to have temperature in our first column. Then I want the values of the voltage, the values of the current, and then I want to measure the resistance. I can measure the resistance by doing V divided by I. Okay, so we're going to change the temperature. So we heat it up. Yeah, so room temperature, then we just heat it up. What's going to happen? So we'll notice then, we'll get the following graph. If I plot the graph of the resistance, so this is resistance on this axis, against temperature, what happens is we'll get the following graph. It will drop down. Okay, so that is a graph you have to memorize for the GCSE. It's very simple. It's as you increase the temperature, the resistance drops down. So to summarize, as the temperature increases, the resistance, what's happening to it? It's dropping down, decreases. Simple stuff, yeah? So make sure that you identify what we've been doing. So we had the thermistor, we heat it up, we change its temperature, we take the measurements of voltage and current, we calculate resistance by doing V divided by I, and if I plot the graph of temperature against resistance, we see it drop it down, all the way down. Okay, and this is just for a thermistor. And you have to memorize that graph, guys, to answer a couple of questions. Right, so let's test our understanding. What's going to happen to the brightness of this bulb over here as the temperature decreases? Right, you already know that we've got the following graph, resistance and temperature. And the graph drops down like this. It's a bit better. Oh, that curve is a bit awful. Let's drop it down. There we go here. So as the temperature is going to decrease, what's going to happen to the resistance? Temperature decreases, the resistance is going to increase. Look at that graph. The temperature drops down, the resistance goes up. So as temperature decreases, the resistance will increase. But if the resistance increases, what's going to happen to the current in my circuit? So if the resistance is high, the current will be low. So therefore, second bullet point, therefore the current will decrease. Now, if you've got less current going into your bulb, what's going to happen to the brightness? The brightness will obviously decrease. So therefore, the brightness will decrease. Simple stuff. Right, summary for this part of the chapter. So thermistors are resistors which are dependent upon the temperature. And here's the symbol over there. They're used in thermostats or air conditioning units. Why? You want them to modify according to the temperature, so they change automatically. Notice the temperature changes, it changes the resistance in my circuit, therefore the current will change. As the temperature of the thermistor increases, the resistance decreases. So that's the last bit of the graph. As the temperature goes up, and I go across, the resistance is going to drop down. And that's it for another session in CeerazzleDazzle Physics. I shall see you next time to talk about more stuff, crazy stuff, including LDRs. Have a good day. Goodbye.